So look at this one here, and y'all have any ideas on how you might factor it? Know where to start? Well, you could take x squared out of the first two terms, but you can't the last one. So it's going to be something like this. You're going to have to do this kind of factoring. Well, let's do like we should always do and look at the second sign. What does it tell you? One positive, one negative. They're going to be different, right? Okay, so we know it's going to be plus minus. Well, what are you going to put in that first little term there? X squared, good. Because what is x squared times x squared? X to the fourth, right? All right, now what factors of 36 will we use? 9 and 4, right. Which one needs to be positive? 9, right? Because look what you have here in the middle. You've got plus 5 in the middle, right? And if you really wanted to, you could FOIL it and check to see if you did it right, but that right there is sufficient. Okay, so we have factored it. So now what you would do is set this equal to 0. And something that we talked about on Friday was when you have x squared in a number, the easiest way to solve that is to move that number to the other side. And then we do the plus or minus square root. Can you take the square root of a negative number? Are you sure about that? Can you? Yes, you can, but what do you get? No, you don't get a negative number. What do you get? Do you remember from Algebra 2 what happens when you take the square root of negative 1? I, yeah. What's that called? I stands for what? Imaginary. Okay, so you get a complex imaginary answer. So until we get to that in the book, what we'll do is we'll say that there is no real solution because it's going to be imaginary, at least for this factor. Now the other one, totally different ball game. We have the other one, we have x squared minus 4 equals 0, and that one we can do because when you move the 4 over, negative 4 over, it becomes positive 4. And what's that going to be? Plus or minus 2, right? Plus or minus square root of 4, which is plus or minus 2. So really, that's the answer. If you were going to answer that question, you could say x equals plus or minus 2. That'd be one way to answer it. In some books, they'll write it like this and put it with little braces around it. But do it one way or the other there. All right, we've got one or two more to go over from this section. We don't have a monomial or a binomial or a trinomial. We have a polynomial with 4 terms. I don't know. It probably has a name. But I don't know what it is. Maybe. I don't know. Do you remember from Algebra 1 and Algebra 2 what you typically do when you have 4 terms? How? Okay. So that is right. Do you remember what that's called? It's called factor by something. No. No. Okay. Well, let's see. We'll see if we think of it. Okay. So you tell me to split it up. So I'm assuming you're meaning look at this and look at this separately. Okay. So what do you do after you split it up? No. No. Don't do that. Yes. Okay. So we're going to put parentheses there, but I see a problem. That's negative. So how do I handle that? I'll put this in a parentheses for the time being, like you told me to. How do I handle that negative? Change the sign. Excellent. So that negative 8x becomes positive 8x, and the negative 16 becomes positive 16. Okay, so we're getting started there. So we separated it using parentheses. Now what? No, because they're not multiplied. They're subtracted. That's why you can't set them equal to 0. If they had been multiplied by each other, yes, you would have set both of them equal to 0 and solved it. But if it's added or subtracted, you got to do something else. So remember some algebra 1, algebra 2 here. What do we do? Yes, factor out what? Not x to the third, x cubed, right? And what would be left? Excellent. And then we had, what would we factor out of the second part? 8. And what's left? Ah, those parentheses are the same, aren't they? So what can I do since those are the same? You don't cancel. Kind of, sort of, but you want to do something that starts with an F. Factor. I should have said, watch what you say. Okay, factor. Yes, you factor. Okay, how do you factor? Or aren't these in both of them? So how do I? So I just write it down, right? I'm gonna factor that out. What's left? X cubed minus 8x. And now it's multiplied, right? Okay, so it was adding and subtracting up here. Here and here it was adding and subtracting. By me fact, yeah, now you set them equal to 0. Alright, now on this one you move the 2 over, it becomes negative 2, easy easy. Now on this one here, it really depends where you are in the book. Now right now we're only interested in real answers. We're not doing imaginary complex answers yet. We're not doing any non-real answers. So for now, you can get by with moving the 8 over, the negative 8 over, and x equals 2, because on cube roots, you just do the positive. You don't do plus or minus on cube roots or fifth roots. Now, if I ask for, and I'll be doing this in a chapter or two, when I start asking for all solutions, whether they're real or non-real, then you'd have to do a whole lot more with that. But for right now, this is all we need. All right, is this coming back to you a little bit? Just a tad? All right. Okay, we got one last thing then, and that is absolute value. No. Okay, no, that is a common mistake, because it is true absolute value of 2 is 2, and the absolute value of negative 2 is 2. But there is one case where it is not positive. What is it? This always messes people up. Absolute value of I. Actually, there is, when we get into complex numbers, there is actually an absolute value of I, and it means something. But let's don't go there yet. I'm just saying that there's an absolute value of one real number that's not positive. 0. Yeah. So you can't say absolute value of everything's positive, because that's not really true. And that gets into some of the special cases that you get into that pops up in the ACT every so often. So what this tells me from Algebra 1 and Algebra 2 is that since I can do the absolute value of 2 and get 2, and the absolute value of negative 2 and get 2, then there's usually 2 answers, right? So if I was solving this, do you remember what your Algebra 1 told you to do? How do I get the 2 answers? That's right. Now here's what people mess up though, is what do you make negative? What do you change the sign of? No, that's where people mess up. Yeah, you don't, no. You only change that. And that's a common mistake. Don't change what's in the absolute value. Only change the number that it's set equal to. It's a common mistake. So if I move the 3 over, the negative 3 becomes positive 3. Here, you don't have to show all this work if you don't need it. But that answer becomes 15 halves. And then if you move this over, you get negative 9. And so the second answer is negative 9 halves. Questions about any of that?